My name is Stephen Gord, Executive Director of 100 Black Men in New York, and I am here for our kickoff of our summer robotics program, where we're looking to gain some interest from people within the community. First of all, I would like to thank York College for being an unbelievable partner in this program and helping us to bring what I think is a very valuable opportunity for the people within the community. If you're not familiar with robotics, it is something that actually helps us to, it's a strategic way for us to promote STEM, the disciplines of science, technology, engineering, and mathematics. And we're hoping that this is a way that we can garner interest of the people within the community, starting as young as middle school, 6th graders, 7th, 8th graders, as well as touching on our high school. And we actually have 2 different levels of the program that we are actually trying to promote. For the younger kids, it would be the, what we would call the it would be the Lego League, where they're actually learning to build robots. They're learning at the most infancy stage of engineering, in terms of how you construct something, how you look at plans and read those plans and develop something that can actually work or function to do a number of different things. In addition to that, it also promotes mathematics and just working out calculations as it relates to being able to program the, learning a specific program that allows the robots to follow different commands and operate through an actual field. And then for those high school kids who are actually a lot older, we have a more challenging component, which would be geared directly towards them, which Dan from your college will be taking a lot of the young people through and just teaching them how they can learn and incorporate robotics into hopefully their curriculum, as well as maybe that's something that can be a vocation for them down the road. I would say the program that we're hoping to sign people up for is actually a 5-week program that would begin actually June 23rd. It would run 4 days a week, Monday through Thursday, with the younger group going from 9 to 12, and then the high school students going from 1 to 4 p.m. It's a very exciting opportunity. We kicked this program off last year. We're hoping to do it this year, and we're hoping to get as many people as we possibly can. Well, I will say it's a first come, first serve. For the younger people, it would be up to 25 students. For the high school, it would be up to 25 students. But again, it's an opportunity that we hope people will sign up for. If you are interested in working or being a part of the Summer Enrichment Robotics Program, you can call the 100 Black Men office at 212-777-7070. You can go on our website at www.ohbm.org to access the application, as well as you can also go on Facebook. You can go to the York College Facebook to look for information for the Summer Robotics Enrichment Program, or you can also go on to the 100 Black Men's Facebook site at 100 Black Men of New York to get the application. So again, the opportunity is here. We'll hope you'll come out. You're going to hear more from Jonathan Quash as well as Dan Phelps from York College, and thank you for coming out.
So we're going to introduce Dan Phelps now. My name is Jonathan Quash, Director of the Male Initiative Program, and Dan is going to walk us through some of the different levels of what we're going to do this summer, as far as particularly with the older students, which was the afternoon students, the college age students. So Dan Phelps will talk to you now.
Great. Hello, everyone. The summer program here at York College is going to incorporate middle school, high school level students, but also students from York College, so collegiate level students. There's lots of different types of robots that you would call it. These would be automated packages of machinery. Okay, robotics kind of encompasses a lot of what STEM and STEAM is, okay, science and technology and engineering, mathematics, but it incorporates it in a package that you have to kind of, to complete a goal, you have to learn lots of different technologies and applications of those technologies to make it. So at its most basic level, We have controlled robotics, such as we have very simple control types of robotics that, at its most basic level, it's a battery, some motors, and a type of application. So in this case, I have a really cool robotic arm here that does one thing. Okay. Now, at its basic level, this is all robotics is. Okay? It's creating a device that accomplishes a task. Now, that device and the task has an infinite amount of possibilities. But once we move up from a basic level function like this, like the robot arm, we go on to more complex level function robots. Okay? And when we get to robots that move, there's all different types of locomotion. So in this case, we have a hexapod, so a 6-legged locomotive robot. And this guy's kind of neat. He walks and spins just like a crab. And he does it okay. He's kind of got a limp leg in the back, but that's part of the trying to make it all work together as a complete system. Now, this is a very primitive robotic system. Right now, it's just all it's doing is accepting commands from just a generic remote control that I have. But if we wanted to, we can put different sensor packages on it. We can give it eyes, we can give it ears, we can put sonar, we can put lasers on it. We can, from an art background, we can put a case around it and make it look like a real crab. There's lots of different things that we can do. And all that's well and good, but the summer program here will attempt to provide a space where you solve a problem. So using robotics to solve problems is really where the learning takes place. So I'm going to have this guy walk around a little bit, maybe just do a little bit more things. So as we move on to more complex robotics platforms, we use what's called Arduino as a platform. And this is just a very small microcontroller. If you take a look at the hexapod here, she's got what looks like a computer on her back. Now that computer provides all the logic, okay? It provides all the thinking, it provides all the communication, but it's also where the code that we create is stored. So when you do the programming, it's stored on these little chips, and it's executed on this device. This is another Arduino robot, okay? This one's actually called the Arduino robot, but this one uses wheels as locomotion, all right? Now, this guy is actually built to accept lots of different sensors and lots of different packages. And one of the great things about this is it's got a little video screen on here. And this is a kind of like second or third level conceptually as far as the complexity of this device goes. What I can do is I can program movements on this one and then execute those movements. And it'll go forward as many times as I say forward, left as many times as I say left, right, stop, do all of those things. Now that's from a user interactive standpoint, what I'm doing is I'm telling it what to do. Same thing with this hexapod over here. I'm telling it what to do. And as we move forward, okay, as we move forward in the robotics workshop, we won't be telling the robots what to do. We'll be telling them how to think, okay? And that's a very large transition into the field of robotics, because there's simple control, but then there's advanced auto intelligence. Okay, and ultimately that's the kind of environment we want to harbor here at York College and in the greater New York area. So if we move from the robots, I have another robot here. This one runs this very simple routine, very primitive routine, and it's a dance routine. So if you listen real closely, it will hopefully play some music and start dancing. There good. So we'll have these guys dancing a little bit here. Now once we kind of move up one more level, you know, drones have been kind of all over everyone's radar lately. Specifically, the legality of drones, what drones are. And I tend to not use the term drone. I use it because a lot of people kind of understand what I'm talking about. But technically, this is what's called a quadcopter, okay? Quad meaning four, copter meaning blade. So it's like a helicopter, but it uses 4 rotors to do it. This is technically a drone. Meaning, I can program it to essentially fly anywhere I wish, and it'll execute its program. There we go. Now what makes this one neat is the fact that it's got a live video camera on it, okay? So what we do with these kind of unmanned aerial vehicles is we control it with a very large, complex computer, okay? Via tablet, via the control surface right here. But all the commands are executed through the tablet that goes through an Arduino processor on the quadcopter. And actually, I have to start this up again. Now, if I can talk a little bit about how this entire system works. This quadcopter, this drone, was printed on our 3D printers that we have upstairs. The Performing and Fine Arts Department in the Communications Technology program here in college, we're starting to implement a lot of these types of technologies, not only for STEM research or STEAM research, because art's right in the middle, but for interactive art design. Okay, so using 3D printing, using advanced embedded electronics, you can make all sorts of things happen. And it's our hope for this summer to teach a lot of people. So I'm going to do a little bit more advanced demo now. Hopefully nobody gets hurt. But you'll see over there I have the thing with the little radiation signal. This is a base station. What this is a command center for the quadcopter. And if you look, if I stand in front of here, okay, this is a high gain antenna, and on the back, I have a screen that actually repeats what you see. But the coolest thing about this device is I can fly it with video goggles that connect to what you see there. So it's we call it FPV. It's a first-person view. You guys may have heard of FPV from video games. It's the exact same concept. And since this is a very highly directional antenna, I have to point it at the quadcopter. Okay, so I'm going to attempt to fly this thing, not crash it, which has happened many times in the past. So this quadcopter has advanced electronics that keeps it level. It knows where it is. It knows how high it is. It knows what direction it's facing. Now I'm not flying it all crazy in here because it's a very dangerous piece of machinery. But the electronics that are in it are highly advanced, okay? And the reason that we can do it in this environment is because they're very, very inexpensive now. So if I crash this, it's almost kind of disposable, if you can believe that. All right? And because it was 3D printed, when I crash it, not if, but when I crash it, I can just reprint out the 3D parts and reassemble it back together. Or modify it and make it better. So this is the third iteration of this quadcopter that I've built. And I've added lots of enhancements to the cameras, to the battery system. But more importantly, you'll see that there are LEDs on the bottom. And the reason why we do this is when it flies really close, it's easy to tell what's forward and what's backward. But as it gets farther and farther away, I don't know what's front and what's back because it's shaped like an X, okay? Unlike an airplane where it has a definitive front and a definitive back, these aren't quite the same, okay? Oh, I'm going to plug that right there. So this is a really fun machine. And if you guys want to talk more about some of this stuff after I'm done, we can. But, you know, one of the things that that we're attempting to do here at the college is to really try to ease the access of a lot of this technology. Because it's so inexpensive, because it's well documented, and because all of this technology is within the reach of your Radio Shack. This is all stuff that they sell at Radio Shack. We want to make it more approachable because the jobs in the future will directly will directly reflect what these machines can and can't do. And robotics is a great way to kind of get into that, okay? It incorporates programming, math, 3D spatial dynamics, like understanding how to design and print structures. In addition to really kind of breaking down what intelligence is and applying that in electronic form factors such as these guys. So that's about it for me. If anybody has any questions, I'll be around. Jonathan?
So if you have any individual questions for Dan, anyone that's observing, you can come on up and ask more specific questions about the robotics. Or if you want to sign up for this summer's robotics presentation, which is through the month of July, June 30th through the end of July, then come on out and do so. Thank you all very much.